Hi, I'm Persley, and this is my teaching demonstration video for Breakthrough San Francisco. Hope you guys enjoy it. Alright, good afternoon class. My name is David, and I will be your teacher this afternoon. And today we're going to go over how to convert a word problem into an equation. So let's get started. Would somebody like to read the word problem? Phil?
In 2 1/4 hours, the temperature drops 13 1/9 degrees. How quickly is the temperature changing per hour?
Okay. Anybody have any suggestions on what we should do first?
Okay, I see fractions, and we've worked a lot with fractions, so I'm thinking we're gonna have to convert them into some form.
Okay.
We might work with it.
Alright, so we have a mixed fraction, and we're trying to solve for what should we convert it to? Anybody know?
Irrational fraction.
An irrational fraction, exactly. And does everybody remember how to do that? So, you have 2 1/4 hours, and we're going to convert that. So we have 2 times 4 plus 1 over 4, and that equals 9/4, exactly. Very good. Does everybody understand why? So let's say that you have, 9 divided by 4, and you have 2. So you have 2 remainder 1. So this is consistent because, you're dividing by 4. So you have 2, 1/4. So does that make sense? All right, awesome. Okay, let's do it for 13 1/9. So we have 13 times
9.
Good. Plus
1.
over
9.
exactly. So, anybody know what 13 times 9 is?
It's 117.
117.
And
Okay.
plus 1.
13 times 10 is 130. Minus 13 is 117. Everybody see what I did there? You subtract 13, so then it's 9. And you have 10 here, so it's 117, so that makes sense. We have 117 plus 1 over
9.
awesome. 118 over 9. Good. Okay, so we have our numbers now, and the next step, and as a frame of reference, we can look at the tips I created, David's tips for solving word problems. Now we need to figure out what we're talking about. So in this problem, we have several things going on, but the most important things to notice is that we're talking about hours, which is time, and then we're talking about degrees and or temperature. Temperature and degrees are the same thing. Hours is kind of by itself. So, let's set up an equality. According to step 2, write out our knowns and unknowns. So, what we do know is that we have 2 1/4 hours is equal to, we made this 9/4, is equal to 118 over 9 degrees. So, we look at this, and we're like, okay, we don't have our unknown yet, we don't have our x, which is what we're going to find out shortly. But, if you look, we have hours equals to degrees, and that doesn't make sense. Does anybody know why?
Because time is not temperature.
Yeah, exactly. Time is not temperature. It's almost a little too simple to think about, but the units have to be the same for this to make sense. So hopefully our unknown, which is x, which we're going to talk about right now, should resolve that. So now let's worry about our unknown, which is x, and this is going to be something. So we took care of the first part. The second part is how quickly is the temperature changing per hour. Now the key word in this is per. Per is basically code word for division. So think about going 60 miles per hour. If you drive for 2 hours, you go 120 miles. And if you work backwards, you would have 120 miles over 2 hours equals 60 miles per hour. Per being a ratio. So does that make sense?
Yeah.
Okay, awesome. So anybody know in this question what the ratio would be?
Degrees over hours.
Degrees over hours. Very good. Temperature per hour. Degrees per hour. Okay? Now we need to put this x in here somewhere. Let's think about this. Okay, so we have degrees per hour, we have hours and degrees. We need to put this x on one side, either side of this equation, to see what's going to happen. So, does anybody know which side of the equation this should go?
The left.
Okay, let's test it. So, we have hours times degree per hours, which is x, equals degrees. So this is the 9/4, this is the x, and this is 118 over 9. And if we divide hours and keep x by itself, we get, sure enough, that we have degrees over hours equals degrees over hours. Does everybody see why that is? Does that make sense?
Mm-hmm.
Awesome. So x does in fact go on the left-hand side of this equation. So now we can write this out as,
David,
yes,
we're multiplying. We're putting that degrees per hours. We're multiplying because it's a rate. Is that right?
yeah. So temperature per hour. So degrees per hour is temperature per hour. So if we set x up as that, and we divide the hours, we get degrees over hours, which is x, equals these two things when they're divided, which we're about to do.
Makes sense.
Okay, great. So 9/4 times x, as we saw, equals 118 over 9. Now we need to cancel this 9/4. Anybody remember what we multiply a fraction by to cancel it?
The reciprocal, right?
The reciprocal, exactly. So you just flip. So you have 4 over 9, multiply 4 over 9 on both sides. 4 over 9 times 9/4x equals 118 over 9 times 4 over 9. And this would be 36 over 36, which just becomes 1 times x equals 118 times 4, which I already did on my calculator, which would equal 472 over 81. And I also did this in my calculator. This would be equal to 5.827, yada, yada, yada. And if we actually took this answer and multiplied it times 2 1/4 hours, we would get something very, very close to 118 over 9. Does that make sense? Last thing about this problem, let's not forget that we're talking about units here. So what is x actually equal to in terms of units?
Degrees per hour.
Degrees per hour, exactly, as we did right here. And as we would do right here. Okay? So our final solution is 5.827 degrees per hour. That is the rate at which the temperature is changing. Any other questions? Okay, awesome. Thank you guys.